this one?
Yeah.
So, this is what? What is this graph, this visual? Go ahead, Annie, since it's your turn.
Fox and whisker.
Say fox and whisker plot. Cool, quick. Alright, so
Hold on.
why do we use fox and whisker plots? Now, let's try an experiment here. Because I respect you guys a lot, but I'm trying to figure out if you respect me equally. True confession, who didn't do this problem yet? I mean, it's not due today. It's fine. Like, true confession, who avoids problems like this because you're still like, okay, that's good. So as long as we just like maybe didn't get to it, fox and whisker plots are a great data representation. So you have to understand why we're using it. So it says, based on the plot, what percent of students watch more than 10 hours of television each week? How in the world am I supposed to know percentages based off of this? Well?
Okay, so it's split in 24, 25%. If you look...
Keep talking.
Okay, so in the first quadrant is like the 0 line to like the start of the bar. That's 25%. Then that's 25%. Then that's 25%. And then the huge gap is 25%. So
Why is this so much bigger? What does that tell us about that section of 25%? Keep going.
that a lot more kids watch, like, not a lot more kids, sorry. 25% of the kids watch more than 10 hours.
The first thing Bola tried to say is the mistake everybody makes. This section of kids, calm it down, air traffic controller. This section's planes coming. This section has the same number of people as this section. So what this actually means is this is more spread out. And this is tighter distribution. Rachel.
Well, it also, like, yeah.
Okay.
Plane has already landed. With the snake and the Cheerios.
Alex.
About 50%.
So, check. Calm it down. 10 hours, right? So go track your 10 hours. This, if it's asking percent, this is just 25% because it's saying more than the 10 hours. So this tracks down to 5. This tracks down to 0. So apparently nobody watches negative amounts of TV.
Is that even this is not possible.
Based on the plot, I'll come back.
Dude, I don't want
What percent of students watch less than 5? Well, so you look at the 5, go up to your data, and look at how many quadrants do we have, and that tells me 50%. Yes.
Okay, so I know the answer to this, the first and the second one, but my question is, you know how it's more than 10 hours?
Mm-hmm.
What if some student, you know how the quadrant 3 starts
Yeah.
at 10 hours? Would it be less than 25% because it's more than, not more than, or equal to?
So you're making those arguments that are really good questions and don't have great answers. So if somebody reports 10, it comes down to when you look at your data laid out, literally the numbers, where does the quadrant split happen, which we're not that deep. So you could actually figure out, is the person who answered 10 over here or over here, or are they the point that we split at? And there could actually be a 10 here and a 10 there and a 10 there. Depends on how many people said 10. Right? Can you use the plot? I'm going to skip C, because can you use the plot to find the median? I want to see your guys' answers for C, so I'm skipping it for now. Nina, what do you think?
Yes, you can, because it shows
What's median mean?
in the middle.
In the middle. Median's the thing in between the lanes on the highway. You don't want to hit each other. So what is it?
5.
5. Yes.
I want to do the next one, the
Me. But I said I was going to skip it. Fine, Rachel. What about the mean?
You can't figure it out because you need, like, every number that it actually is. You need to have, like,
Well, wait, if I don't have every number, how do I know that the median's 5? But you said I don't have the numbers.
You don't know the need because you don't know how many people answered that exact one. You know they're all equal, you don't know how many that is.
We know that there is a 5 in the middle. We don't know how many 5s there are. We don't know what numbers are below 5 or what numbers are above 5. But that point on there tells us there is a 5 in the middle. Because that center bar of my box is the median. So no, we can't find the average, but we can find the median. Alright, let's move into today's lesson. Or any other questions from last night, because today's lesson is actually going to be pretty quick, I think.
What's the lesson for today, Paul?
7 to 1.
Yeah, I know, but like what's
I don't know what I put
Finding
that
missing
to.
information in proportional relationships.
There we go.
That was crazy.
That was like surround sound right there. So, these skills should be like starting to be fairly concrete. This should be like, oh, I know how to do this. So if not, you need to step up your game and really work that practice today. So check out 96 with your partner. How can we find the value of the unknown in this proportion? So take like a minute or so. Then we'll use random cards. Get some more. I'm sorry. As long as you know what X is. Alright, now unfortunately, this has another way to solve it. Mia, so how'd you solve this? We're going to look at a couple different ways to solve this.
I did 3 divided by 7.50 and then times 3 by 10 times.
So you found essentially like the unit rate of, well, you did 3 divided by 750. So that would be pounds per dollar, actually, is the unit rate that you found. Now that's kind of a messy division. Ian had an interesting way to look at this. Ian, what did you say when I came around?
I said 750 divided by 3 is 250, or 10 divided by 250 is 4.
So Ian like flipped it, and he said, well, if I think about 750 over 3, it means each pound is 250. If I'm adding 250 here, now we don't add in proportions, but Ian figured out the proportional relationship. If I'm adding one more cost of a pound, I add one more pound, and this becomes 4. Let's assume these numbers are super complicated, because before we get any further in the lesson, I want to remind you of this. Let's say this is 3 over 7.62, and we're like they've just chosen a weird price for the poundage, and we end up purchasing 47 and 94 cents of whatever this is. Well, in real life, things don't come out to whole numbers. How can we always solve any proportion? How can we always solve any proportion? Rachel? Cross multiplication. Now, without going through the entire process, there's another way that we can essentially use cross multiplication without doing that whole process. Cross multiplication, I would multiply these and then end up dividing by the 7.62. That will always work.
No, I know what cross multiplying is, but like when you did the thing, why did you divide it by 7.62?
Because you end up with 7.62 times your x equals whatever that multiplication is. To get the x by itself, we divide by that 7. The same exact math. In your eyes for a second. I'm just showing you this because it's kind of a more advanced way of thinking about it. Think about the scale factor. From 762 to 4794, there is some kind of scale factor that's probably a mess, but there's a number there that multiplies from the one to the other. How do I figure out a multiplication if the numbers are messy? Alex? Just divide. Hope you're coughing into your shirt. Somewhere good. Vampire. 4794 divided by 762. This is 6.29133. Do I need to write this whole thing out or no? Because if I leave it in the calculator, I can then just hit times the 3. Because that's the scale factor that will happen to top and bottom. We just did the same math, essentially, as cross multiplying and dividing. We bought 18.87 pounds of whatever this was. Havarti cheese. Oh, I'm down with that. I love cheese. I'll take 18 pounds of Havarti. Yeah, that's 87401, but I mean, on the scale, it'll round. So since this was a 4, it doesn't affect the 7. 5 or higher. I just normally go hundreds first. Yeah, it's good money. Hundreds of thousands is safe. All right, questions. Because these get harder. I lost my other post-it.
In case someone can by 80.
Has anybody ever actually been paid by the half hour? I'm curious. Like babysitting or anything? You know?
I don't think
What is more common? Hourly, right?
Oh, double that.
Can I figure out what she solves? Or not solves, but makes hourly?
Yeah.
How can we do that? Double it. So we can actually make $8.46. And then we don't need to cross multiply. The scale factor on this one is still kind of easier. I know. I just wanted to show you another one in between. Because here's the thing. I love that you recognize we can just multiply that by 80. But what if she's only expecting to work 40 hours, but she actually only works 36? Then that, like, you have a bit more thinking to do. Like, oh yeah, we can multiply half by 72. We could still figure it out. But knowing the unit rate is always convenient. So I just wanted to make sure that we looked at
Wait,
the
so if the unit, if the denominator is like lower than 1 and you want to figure out the unit rate, you actually increase it?
because we done it. So then we multiply by 40. Well, times 10 would be 84 times 4. What do we get for 40 hours? You said 338.4?
Yeah.
And it's money, so you have 2 decimal places. Like always 2 decimal places in money. Now wait a minute.
tried to cross out the X and it didn't work.
Crap.
What?
C.
Oh,
Try C.
Oh,
Try C.
oh.
Shh. Well, that's okay, but don't say math out loud. Talk with your partner. Solve on your paper. Figure out how long it takes Granny, I don't know, Granny to earn $1,000. She wants to figure out, can she earn $1,000 this summer? Well, okay, fine. Gender fluid. I don't know. He, she, I don't really. These are fake people. I'm sorry.
You hurt his feelings.
I'm more worried about saying that. G. We'll call him G. How long does it take G to earn this much money?
I don't know.
Okay, yes.
Yeah, I'm gonna try some other stuff. You feel like
Can anyone do this without a proportion?
Oh, I did.
From you guys.
We used to calculator.
So did they.
Who has it solved with a proportion?
Oh, that's
You did the equation. Who has it solved with a proportion?
I don't know.
If I set up my proportion like this with the unit rate, then Ava, what do I put where if I'm going to use proportion? Now what's funny is what you told me to do is still what we're going to do, like what you said as I walked by, but I'm going to do it in a proportion. Would the 1,000 go numerator or denominator? Numerator, right? Because it's money. So now as I walked around, Ava said, well, wouldn't you just divide 1,000 by 846, like what you make every hour? Yes. Because that tells us the scale factor from an hour's pay to $1,000. Did you get this route, like 1,000 divided by, what is that?
118.20.
You said and.
Yeah, I know. That's confusing.
118 and.
20.
Wait, what?
Point zero.
0.2. Okay. Sweet. Like it. I like rounding. So this multiplication by 1 doesn't do anything. So our answer is just that scale factor. Now, hold up. Rachel is landing planes over there and says that she solved it with an equation.
I did.
What is your equation?
1,000 divided by 8.
That's not an equation. That's an operation. Nina?
What? You did the exact same thing I did.
Piper?
The equation that you figure out any value would be, I use x, y. Y equals, what do you mean y equals 8 times x? Because if x is the hours, and you multiply it by per hour, and you get the values.
This is a linear relationship. This is a proportional relationship. 0 hours, 0 pay. As I get more hours, my pay increases with it. So I could either plug in hours or I could plug in pay. This is why we use the unit rate. So sorry that I was like, but that's why we use the unit rate. Because the half-hour pay is like really annoying. Once I go to unit rate, I can set up a wonderful equation, whether I know hours or pay, doesn't matter.
Okay, but you're going to use the half-hour pay and then just multiply the whole thing by 2 at the end.
Yeah, but you just did the same thing, just in a different order.
Okay, yeah, I know.
We're saying the same thing. I agree. You're fine. Yeah. You just have a bit more sass than me.
Because she's hanging out with me.
Try this. These numbers don't work well together. So, hold on. You got a bit of reading to do, a bit to think about. So, cool it with your conversations for a moment. Check out this problem. Eventually, they come up with a couple equations. We're gonna have to help them out.
What's a couple?
A couple equations. So they have this equation. They have that equation.
What's a cupboard?
No, like
Cupboard. That's a cupboard. It's a cupboard because it's the board you put the cups on, not written. It's a cupboard. Cupboard. Why it's called a cupboard?
I swear I thought of you.
Oh, you can. That cupboard is solid. Oh. I want it nice and
yeah, that's true. I mean, it works out.
If you were in Mercedes,
I swear I thought it said cupboard, and that's what I read.
start writing work. Come on, guys. You should have a book in front of you. If you're behind, you should. Don, I'll see you at math lunch, right? Don. Math lunch? Yeah? Yeah. Your answer is yes.
I would also probably be there.
Sweet. I'll sit next to you.
Yeah. That's how you got here.
No, you're coming. Then I don't care about you, I did.
Please, you care about me.
Yeah, for sure. Oh, what a.
wait, okay.
So, you notice that we haven't been using giant one and two right now?
I know.
Well, your giant one is not right now. Because what you would be saying?
We have two ways. Yeah, but what? I don't have the answer though.
We can multiply to the left, right? So if you're going to make a giant one here, you're saying you're trying to turn your denominator into 1, right? What do you multiply 2 by to make it 1? Half. So we'd have a half over half. So if you use giant 1, we get that. 2.5 cups over 1 recipe. This is supposed to be giant 1, but
If you do 2 divided by 5, that would give you the 1 cup per how many recipes?
So then isn't Carolyn correct?
2 divided by 5 would be recipes per cup. So right now we have cups per recipe. If you read it in
Well,
order,
if you use 1 as 1 cup.
recipes per cup. Yeah, so if you flip it, if you want per 1 cup, you can do 2 over 5. When I do that division, which comes out to be 0.4, that's recipes per cup. I can make 4/10 of the recipe for every cup that I have.
Yeah, okay. I did this right.
So if you read what's quoted in italicized, they tell you the work that I showed. If it takes 5 cups of flour to make 2 recipes, then it takes 2.5 to make 1, right? Cut them both in half. Then they say this is the multiplier. Can't you just use the multiplier and write an equation? So Carolyn writes F equals 2.5 R, and then she says this. Is this what we want to do? Why? No. Why is this what we're doing? How? Because I know Piper gets this. She did it on the last problem. But why? Like, how do I get this? What does this mean? And then why am I, like, why does Shiloh or Carolyn or whoever writes it? Why do they write what they write? Huh?
So 2.5 is for 1 recipe.
So that is our, what do we call it? Unit rate.
No, not a fantasy. Anyway, so we have to multiply it by how many recipes we need.
Once we have the unit rate, then, exactly like Alana said, think about what's getting plugged in. Is it number of cups getting plugged in or number of recipes getting plugged in? We would want, in like a normal kitchen, to know the number of recipes. How much do we need to make? How many dozen? How many batches? Whatever. And then figure out the flour. However, in this kitchen, they're like, we have 13 cups of flour. How much can we make? Is this right? Yeah, because 13 is the cups, right? It's the amount of flour. How? Now here's where it comes down to. How do I solve? There's like 3 different ways here. I have one very efficient way that I want to make sure we think about. Alex?
Divide 13 by 2.5. Yes.
I like it, but I want to make sure that I show the other way. So that's a really good way if you have a calculator. Okay, so your way is perfect if we have a calculator. But Mr. Webb stole my calculators this morning, and I was thinking about, what if I didn't have them and I was making you guys do calculator lists math? 2.5 he teaches in the academy. I know he brought them back. How could I turn this fraction into 1? Multiply by the reciprocal, which becomes, what's 13 times 2? 26 over 5. What's this? 5, yeah, with a fifth left over, or 5.2. So we could make just over, sorry, not a half, a fifth. Sorry. We could make just over 5 recipes, or really be safe and make 5. Have a little bit of flour left.
I love that strategy, but I never remember to do it.
What, multiply by the reciprocal? That's why I'm going to keep bringing it up every time we look at situations like this. So, when you have a calculator, do what Alex says. If you're using a calculator trying to be fast, just divide by your multiplier. So Alex said when this is 2.5, just divide by 2.5, and you get 5 1/5 or 5.2. Very good. Questions?
From a Paul math kid. He said that 0.9 repeating is equal to 1.
There's a proof that we will look at.
I mean, if you round.
Yeah, but like not rounding.
A little hard.
Any method you choose, solve these. Any method you choose, solve these. I'm just going to give you your answers. Then if you're upset by the answer, we'll review.
Mr. Hudson, I don't understand any of this.
Who just asked that? It is 2 divided by 3.
What?
Somebody said, what is 2 divided by 3? Loud enough for us all to hear. It's 2 divided by 3. Leave it. But the decimal approximation is sticky. 0.6 repeating forever.
Can't you just make it 2 this?
Ooh, so a few different techniques, right? And people are saying them loud enough that now I just kind of, you can keep solving on your own if you want. But somebody said, what's 2 divided by 3? Who said that? Rachel, why'd you say that? So, to go from, yeah, it's like our scale factor. Hey guys, hold up. It's like our scale factor. So really our scale factor here is a third. How do I go from left to right? Guys, x, leave it as 2/3. Unless we tell you to put it into a decimal, leave it.
But then it's a fraction of
No, because we're solving for x. You would just say x is 2/3. Like whatever you were, like whatever the x was representing. I mean, yeah, it would be a complex fraction, but that's okay. We don't like to mix decimals in fractions. So that would look like 2/3 over 5. Like, and you just make these smaller and that bigger. Now, does anybody know the scale factor to go from 8 to 100? Yeah, it's actually 12.5. But most people don't have that memorized. Here, if I was you, I'd probably actually cross multiply because the numbers are easy. 7 times 100. Remember, a bunch of ways to solve this. A thing. Yeah.
Okay.
I think it's going to be more than 8. 87. No, scale factor. If we use the scale factor, we multiply by 12.5. If you know what the scale factor is. In C, that's your X, and in D, that's your Y. You got 8 minutes to work on your homework. We don't like it, but we're not putting it in the fraction. We're not substituting it in. We are solving for the unknown. We're using, that's not even really a fraction, that's a proportion. So we're just setting up the equivalent ratio values. And it doesn't matter that we have 4 over 7 equal to y over 11.2. It's like that 11.2 is representing some quantity that is like a tangible amount. So while we don't like it, we could make it an improper fraction, become a fraction in the fraction. That'd be more complicated, right? Have a fraction in the fraction here. So while we don't like it, when we work with proportions, you can plug into whatever you want. Fractions, decimals, you don't go like that. You can plug in whatever you want. It's just I don't like it, but we do. Yeah. Sure, yeah. Bring headphones or get spoons or whatever. What do you mean? What is that? When do you do that? Okay, so we're looking at comparison of values through scale factor. Is one way that we look at this. So, if we look at 15 and 5, 5 is 1/3 of 15. So you either multiply by a third, which when we use scale factor, we talk about it with multiplication, or we divide by 3. Since that happens on the bottom, it has to also happen on the top. It has to agree. So my concern with what I see here is you don't really have any work to support what you did. You didn't really write out like when we drew the arrows or the scale factor or how we figured this out. You're just like writing the end. Right? So you don't have here that we actually started with the half hour. You didn't write the original, you don't have your book out, you're kind of putting in like half hour. So my advice would be go back and watch the video once it's uploaded, rewrite your notes better, or copy somebody else's notes better, with, like here, you don't have the scale factor that we multiplied. You don't have how we found this out. You're not even writing down what we're writing down. So if I flip back to 79, or sorry, 97, I'm dyslexic. what we should see here is not just the fact that we found this number. It's that this was an original value. And to find this multiplier, we did, and if you don't understand this, you need to write it out. We did division to solve that. So to find that multiplication factor, we did 1,000 divided by the 846, which equals that 118.2. That's how we find out the multiplication. If you don't know how to multiply forwards, you divide backwards, which then tells you the number will multiply by. That's what you need to understand, is we do the same down here because it's what happened on top. Now, because we're not working with like terms, like dollars and hours are not like terms, we can't add or subtract anything. Like if someone says, well, add 2 hours, well, then on top, I have to add 2 hours worth of money. So that's why we don't look at addition or subtraction, because that would be really complicated. But if somebody says, okay, triple the bottom, instead of add 2 hours, like triple it, turn it into 3, on top, triple your money. So that last question that we were trying to answer there is how long does it take to, well, not last question, but here's part C. How long does it take to make $1,000? So we had dollars compared to dollars. We were able to do that comparison, and the bottom has to have the same comparison, which, while it's a bad kind of ugly number, 118 point whatever, I can multiply with that number. And we do that on the bottom to find the answer. So that's like the work that we need to see, so we understand how we get there. But here, what did we multiply by to solve for that? So forget about this first part right up here. Yeah, because we're comparing the values we have that can compare, the 1 hour to 40 hours. That's a times 40. Top has to be the same thing. We're always looking for what scale factor takes us from 1 value to 40. You don't have anything written out there. The actual equations that were used here, you don't have anything. So I am sympathetic to you not understanding it and not putting in the effort. And also, when I ask in class, if anybody have questions on this, don't ask. I can't stop and explain it right now. If you don't ask. Alright guys, back it up and head on out. So if you want to do the math test, I can help you with some of your homework or whatever, but I can't do much for you not writing up the work and then saying, oh, I don't get what I didn't do. Well, if I have never built an application before, I don't know how to do it. You gotta practice it. You learn by practicing, right? So I wouldn't just say like, hey, I don't know how to build my IKEA kitchen when I've never tried it. Well, of course I don't. Like, so it's okay to not know at the beginning. But then you practice and then you figure it out. Oh yeah.
It just made me laugh.
I'm a liar.
At lunchtime.
Yeah. Alright. See you later, peeps.
Yeah.